everybody. My name is Kolin Konjura. I'm talking on AI TechOps. Really what we're talking about today is data and infra for AI and how we scale to thousands of cohesive agents within an agentic framework. This is our contents, right? So we're going to talk about infrastructure, example architectures, as well as some core components that are all enabled through cohesive agents. So as I mentioned, my name is Kolin Konjura. I'm a data science solution architect at 66 Degrees. I specialize in MLOps, deployments and scalability. I'm in New York City, and I have a master's in mathematics. In general, 66 Degrees is a Cloud Premier partner. So we partner with Google. We've won Partner of the Year. This is actually an old slide. We just actually won Partner of the Year this year as well, which is pretty exciting. But in general, we have a large number of people that within our company that are very familiar with the Google ecosystem and that Google forward mentality. These are just some of our brands that we work with. You might recognize a few even at this conference, which is always great. So what do we think of when we think of cohesive AI agents? Well, let's start at the beginning, right? So kind of a fun little diagram. Traditional programming, so I'm kind of dating myself here, but I remember learning Java back in the day. We'd have objects and classes and methods and all kinds of things where we had to actually define what a cat is. Then there were neural networks, right? In the early to late teens, showing a bunch of pictures, right, of is this a cat or not? Now we've got generative AI, right? Generative language models that allow us to say, what is a cat, right? And we get to ask different questions about the authenticity of that object, right? This evolution has taken hold, and we're now dealing not just in years, but in months of evolution, right? So what does this really mean, right? When we think about the rise of agentic AI, we're really thinking about, right, from late 2024 on, we're talking about human AI collaboration. We're talking about increased demand for efficiency. We're talking about advancements in AI technology. We're talking about global adoption across industries, right? This is no longer about use case by use case. We're talking about enterprise level transformations, which is really cool because we went from, right, monolithic architecture to agile or microservice architecture, and now we're moving into agentic architecture, right? This idea of all of these small little widgets all coming together to actually be within a single pane of glass, right? How does one user interact with all of the different systems? We have, I don't know, at our company, we have 15 different places we have to log into every day. But like, what if we just had one? Wouldn't that be awesome? I'm really sick of putting my password in. So these are a bunch of different use cases within the Gen AI space. I'm sure you all kind of recognize a lot of these things. Some of these, you know, have been developed and actually mostly solved in the past year and a half. But as we think about these, we start thinking about, okay, well, we've got, let's say, 30 bullet points on this slide alone. We can all each individually think about 30 more non-overlapping points. How do we bring all these things together, right? How do we think about actually pairing up and creating collaboration within our ecosystem, within each of our companies? So this brings us to agents, right? We've kind of all probably become a little bit accustomed to the word agent now. It's been around for a few months, which is, again, kind of hilarious to me that we're moving in the months. But when we really think about this, we're really thinking about how do we reason over goals? How do we determine a plan? How do we generate a response? And how does an individual interact with that agent, right? Additionally, when we think about cohesive AI agents, we're thinking about groups of agents acting as a system. So if we think about the human body, for example, right? Cells turn into organs, right? Organs turn into systems. Systems turn into humans. Same thing, right? We're moving into this system-oriented architecture for agents. But the issue with systems is that you have to have some level of orchestration, you have to have some level of scale. So let's talk about architectures. We've got a single agent architecture, for example, right? Powered by a single LLM. This performs all of your reasoning, all of your planning, all of your actions. It's relatively simple. We give instructions, we get a goal, right? We've all used these things. All of our colleagues have used these things. I have cousins that have used these things, right? Like, right? I mean, that's what it's turning into. But how do we scale from a single level architectural, single agent architecture to a multi-agent architecture, powered by 2 or more agents that can be used to coordinate, collaborate, and specialize, that can be organized horizontally or vertically? When we've seen this talk time and time again over the last day, I'm sure we're gonna see it tomorrow, I'm sure we're gonna see it for the next 6 to 8 months, of how do agents provide feedback, and when is that beneficial, and when is parallelization desired between our agents? It's a hard question to answer, right? Like, how do you provide a feedback loop of agents that kind of think for themselves? It's kind of weird. How do we also allow them to pass instructions, right? I don't want one agent that's going to do all of my components, right? I don't want an agent that's going to, for lack of a better word, boil the ocean, right? I want to take multiple agents across multiple regions and be able to do task-based oriented things, and those tasks or those actions, as they're passed through, all of those agents can communicate with each other. That's my ideal. At the end of the day, right, we have a data challenge, right? Time and time again, this is what we've hit in the last 20, 30, 40 years, right? We're always talking about the data. Data is the lifeblood of intelligent agents at the end of the day, right? We've all seen companies start hoarding their data, start gathering their data, right? We're talking about petabyte scale, right? Big data was a huge thing 15, 20 years ago. Then it turned into data mining, then it turned into machine learning, right? All of these things. But we still have it, right? We still have all these data sources. We still have this diverse and massive data sets living throughout our ecosystem of our organization. We still have to maintain our data ingestion and transformation pipelines. And as we saw in the last talk and other talks that we've had, we still need vector databases and knowledge graphs, right? And in fact, we're transforming the way that we do data engineering to keep up with scale, to keep up with the massive amount of data that we actually have to access readily on a day-to-day basis. It's no longer throw it in cold storage and forget about it for 10 years. We have to bring it back. We have to actually start talking about it, using it, and integrating it into our systems. Last thing, right, which I've answered, 10, 15 times today, is how do we talk about data governance and security within these agents? How do I make sure that my data is not constantly being exposed to external sources when I don't want it to be? It's more than just RBAC, right? It's more than just how do I dictate who's using what data. It's I need to silo and start segregating my data. But then that turns into an agent itself, right? Which agents have access to that data? Who has access to those agents, right? And you start creating this hierarchical security for them. This is just a nice little picture of everything I just talked about. So you can kind of see, as we move up, you can start seeing the safety filters and the guardrails and the monitoring and the logging and blah, 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 right? All the things that you would expect. Okay, so now for the meat and bones. Building a Gen AI solution is, right, not easy. We've all done it, right? But at the end of the day, this is the classic data science problem, right? We just moved and called it something else, but it's still the same problem. We still have the model in the middle, right? Which, for better or worse, is the most interesting part of the entire application, of the entire solution. But you need all of these other things to actually make it work. The worst part about being a data scientist in my mind is that when I build a model and I don't put it into production, what was I doing, right? Like, it's just a model. It's just hanging out. Being able to do all of these cool things, right, on top of it, this is what we actually need, right? We need prompt engineering, we need fine tuning, we need model selection, we need data stores, we need ML ops and data security, right? We need all of these things to actually have a fully fledged application. This slide is crazy, don't get me wrong, but when we think about the last slide and we actually put it into how does data flow, this is a fully fledged system, right? We've got agentic knowledge and management, we've got, agentic search, we've got different verticals within our industries, we've got foundational models, we've got platforms, we've got inference pipelines, we've got everything that we need, right? But this is a huge undertaking, right? This is not a one-person show. It's not even a one-department show, right? We need all of these things to scale, right? We need DevOps, we need data engineering. All of these things are AI forward and AI led. And when we think about a solution like this, we have to be structured in the way that we're processing our data, in the way that the data is flowing through to our agents. So let's talk about management and orchestration really fast. One of the cool things that came out of last week, which is Google Next, for those of you that weren't able to attend, this architecture came out of Google Next. What this is saying is that we can actually take now, right? We can take a third-party agent, bring it in via client-server interaction, have it be orchestrated via a host agent, and then orchestrate out and relate to literally another agent that's not related to the first. For example, a Salesforce agent, right, and a LangGraph agent have nothing to do with each other, right? They're not in the same ecosystem. They're not within the same purview. There's no reason why they should be able to talk to each other. But they have to. So this architecture actually allows that to happen because otherwise we don't have an orchestration system where these things can actually start talking to each other, can actually start having data talk to each other, and I can start querying and asking the right questions about these different agents. So the whole point here is that we need to think about dimensions of scaling, right? We have to think about what happens next. We have to think about how do we start provisioning the resources and the architecture necessary to carry these applications, these agents, these personas through. GKE is a good example of this. I'm not going to harp on GKE, but it is a good example of this. There's other ways to think about this too, such as Gleam, such as agent space, right? There's different components in orchestration systems. But at the end of the day, we actually have to start thinking about what this looks like from a scale. So, this is a couple last slides here. When we think about the customer's journey, right? So this is about the customer, whereas the other slide was more about how do we as developers organize our systems. The customer journey, right, and their data. This is how a customer's data moves through a system, an example system. This is more of like a CCI platform type implementation, but at the end of the day, where is data going? How is data flowing through the system? And again, we have to make sure we are getting these nice feedback loops so that we can actually have grounding, so that we can actually have real-time search suggestions, so that we can actually have real-time personalized customer insights and experiences, so that we can react in real time. As the amount of development has occurred within our entire field, the need for data from a customer perspective, the time that a customer demands their data to be retrieved is shrinking, right? We're hitting even closer to near real time, right? We're hitting closer to real time. We have to start building at scale. One agent isn't gonna do it anymore. It's complex, it's hard. We have to understand how to troubleshoot these systems. We have to understand how to debug. We have to understand how to optimize. We have to understand agent coherence. We have to understand how to prevent conflict. within our agents, within our orchestration systems. Who remembers like old school cron? Like 2 people. Awesome. I do. Remember how much of a pain it was, old school cron, trying to organize all these different services and systems? It was terrible. We're dealing with the same problem today with agents, right? It's just the next iteration, the next step. We have to have malleable architecture that allows for flexibility of ever-changing technology advancements. How many people have gone through like 8 models for their architecture in an application? Like a bunch of us, right? Like, that's silly, right? We have to be able to build an architecture that's agnostic against their models. We also need data security and privacy because, let's be honest, we can't build an application without it. That's pretty much it, right? We just have to think about, how do we keep a human-centric approach? How do we create that collaborative power and that foundation for innovation as we really start harnessing this technology and really start broadening out, right? Taking one agent, moving it into a multi-agent architecture, scaling. That's all I got.